We have another type of log equation, and in these equations, there is a log on only one side of the equal sign. You can see there's one here on the left, but not on the right. To solve these, we're going to combine again into a single log if necessary, and then rewrite it. I'm going to underline that in exponential form. That's the thing that you've got to remember that's going to be hard to think about it first. You'll get used to it, but at first you're going to have to watch out for that. All right, so here I have a single log. I'm going to write it in exponential form, so which means I'm going to take the base, which is 3, and say it's raised to the second power, so 3 to the second power is equal to 5x plus 7. And then solve. So I'm going to have here 9 is equal to 5x plus 7. Subtract my 7, so 2 is equal to 5x. And then divide by 5, so I get 2/5 is equal to x. So stop the video and try one just like it. All right, now 21. This time you can see I have 2 logs, and I'm going to need to combine them. So because there's an addition between them, that means I'm going to multiply the 4 times the x plus 2 is equal to 3. Now the reason we did that was the log property that says I can combine the 2 logs that are added into one as multiplication. That's the reason we did this. All right, so I'm going to rewrite that now. So I have log base 3 of 4x plus 8, and put a parenthesis around it, is equal to 3. All right, so now I have my single log on the left, and I'm going to rewrite it in exponential form. So I'm going to take the base 3, I'm going to raise it to this 3 over here, to the third power, and it's going to be equal to 4x plus 8. So 27, so I'm going to have 27 minus 8, that's going to be 19, is equal to 4x, and then divide by 4, and I get 19/4 is equal to x. So that was 27 minus 8. All right, so stop the video again and try one just like it and see how you do. (23). Okay, I just hit the stop button, so hopefully we're okay. Log base x of 144 is equal to 2, so I'm going to write it in exponential form. So I have x squared is equal to 144. To solve it, I'm going to take the square root of both sides, and of course we know that that's equal to plus or minus 12. However, I can't have a base that's negative, so my answer is just going to be positive 12. So I give my practice problem number 2004 over here a try. So let's look at one last problem here. Again, I want to solve this for x, and you can see I've got several logs on this side that I can combine together. It's addition, so that means that when I combine them, I'm going to combine them with multiplication. So 3 times 2x minus 1 is equal to 2. So the log of, and I'll distribute, that gives me 6x minus 3 is equal to 2. All right, so now I'm ready to change it to exponential form, but whoa, there is not a base. What happens when we don't have a base? That's right, we understand that it's going to be a base of 10. So that's an understood 10 right there. So I'm going to write 10 to the second power is equal to 6x minus 3. So 100 is 6x minus 3. Add my 3, that's 103 is 6x, and divide by 6. So I get 103 divided by 6 for my answer.